All right, we're on video, kids. So everybody pay attention. All right, the first thing that we're going to do is we're going to write 3 headings across the top of our paper. We're going to put sublevel, number of orbitals, and max number of electrons. Okay. Now then, our first sublevel we learned about was who?
S.
K. The next one was P, D, and F. Now, in the S sublevel, how many orbitals did we learn yesterday? And we drew a what line? Little straight line indicating. And we only drew one line. So the max number of electrons, now according to Pauli's exclusion principle, the second one, each orbital maxes out with how many electrons? 2. So 2 times 1 orbital, the max number the S can hold is 2. Okay? How many orbitals did we draw for P?
3.
Remember, we went odd numbers, kids.
1,
3.
5, 7. Sorry.
Exactly. Odd numbers. There's a reason I tell you that. All right. So 3 orbitals times 2, because each orbital can only hold how many? 2. 2 times 3 is a total of 6. Okay. How many orbitals for a D?
5.
Okay. So 1, 2, 3, 4, 5. Each individual orbital can only hold 2. So 2 times 5 is a max number of 10 electrons can be held in the D sublevel. In the F sublevel, we have how many different orbitals?
7.
Okay? And each orbital can hold 2. So 7 times 2 is 14 max number of electrons. Okay? I've been so busy I hadn't even looked at my phone. Isn't that terrible? I'm setting such a bad example. All right. Everybody good so far?
Yes.
Okay, so we went over this. All right. The next thing I want you to do is we are going to draw what I call the blocks of the periodic table. What are we going to draw?
Blocks of the periodic table.
Okay. So, looking here, the first 2 columns okay, see what I drew? First 2 columns of the periodic table. Now, if you look over there at my periodic table, who sits above Li? So, H sits right here. Everybody agree? Okay, now who did I move over here for the... So, we're going to put helium right here for the time being. Does everybody understand? Okay. Now then, this is called the S block. How many columns are in here? And it's 2 columns. Okay. Everybody good so far? All right. Now then, I'm going to, do you see how the S block is up and how the P block is up? Yes? And the D block is dropped down? So I'm going to go over here and I'm going to create my P block over here. Okay? Now my P block contains how many groups, kids? 6. And I'm not going to put helium up there, am I? Okay. So I've got to get, there's 1, 2, 3. I got to get 5 dashes in here. 1, 2, 3, 4, 5. And that gives me 6 blocks. Does everybody understand? And so then I draw down. Or 6 columns. Okay? Lord, I hope my sound was on. All right. Now then, so this is called the what block? Okay, and the P block contains how many columns?
6.
Okay? All right, so now I'm going to drop down for my what block?
D.
D.
Yeah.
Everybody see it going across? Okay, so this is my D block. Okay? And it has 10 columns. If you count, starting 21 through 30, you'll see that there's 10 columns there. Okay, so that means I need 9. One, 2, 3, 4, 5, 6, 7, 8. Screwed it up. So do I have 10 columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody agree? Okay, this is called the D block with how many columns? Okay. All right. Now then, the pulled out down there is the F block. And it has how many columns, kids?
14.
Okay. So we're going to do this. Okay. And somehow in there I got to get 13 dashes. Okay, so this is our F block with how many columns?
14.
Mm-hmm. Okay, I'm going to zoom smaller so I can see the whole thing. All right, we're going to make an association with numbers. S maxes out with how many electrons?
2.
How many columns are in S?
2.
P maxes out with how many electrons?
6.
How many columns are in P? D maxes out with 10. How many? Okay. F, 14. Huh, interesting. Okay. Everybody look at the blue number on my periodic table. That blue number increases by 1 every time. Is that right? Okay. Just keep that in mind. All right, we're going to write a little statement here at the bottom of this to make sure you remember every element's electron configuration ends where it lives. Always. Okay? Every element's electron configuration ends where it lives. Always. I'm going to get a periodic table and a filling sequence. Okay. All right. I want to look here. So these two columns are the what block? Okay. These 6 across here are the what block? This is my D block. And down here is my, okay? All right. This is S1. This is S what? Okay. P1, P2, P3, good. P4, P5, helium is not there. Helium is where? And this is P6 on neon. Everybody with me? Okay. Now then this is D1, D2. That's why I had you take a picture. D4, D5, D6, D7, D8, D9, D10. Everybody with me?
Yes.
All right. So I'm basically kind of creating what y'all took a picture of. This is known as 3D1, 4D1, 5D1, okay, and 6D. All right. And these are your Fs. We really don't get down to the Fs, but it's F1 through 14, yes? F1, F2, F3, F4, F5, F6, F7, F8, F9, F10, F11, F12, F13, F14. So it takes 2 elements to fill up an S. It takes how many elements to fill up a P block with 6? How many elements does it take to fill up the P?
6.
6. It also takes 6 electrons. Does everybody understand? So we will stay on a P block. We will stay on a P for 6 elements. We stay on an S for 2 elements. We stay on a D for 10. Does everybody see it? And we would stay on an F for 14 elements before the F would ever get full. All right. With that being said, we are starting. Okay. The paper that you were given for your assignment If you write big, this is not the paper for you. What did I just say? You write big, not the paper for you. Okay? Then you need to use notebook paper, but I'm going to tell you what, y'all better learn to write small. Okay, so here's your paper. Now then, if you look at my board and somebody hit it and erased it, the front page is numbered 1 through what?
27.
Okay, so the first 27 elements will be done on the front page. You will do both orbital notation and electron configuration on the front. Okay. Now, you're going to do both, and I'm going to do at least half of the paper with you. Turn over to the back. On 28 through 54, you're only going to do the electron configuration. Okay. And you will learn what this is and what is the difference between orbital notation and electron configuration. The orbital notation is the line and arrows. The electron configuration is the 1s2, the 2s2, the 2p6, 3s2. That's the electron configuration. On this page, we do both almost simultaneously. Okay? All right, the first element is who? Hydrogen, exactly. All right. So, can you see that your blue number on the periodic table goes just in this order? So this number is telling you already the number of electrons. Remember, the only thing we're working with is electrons, yes? Okay. So the first element symbol is what? H. Now then, this is your off-bow principle, which tells you this is your filling sequence. What is it called?
Filling sequence.
You do not get to make it up. It's written in stone. Electrons will always fill the what first? Give me the whole thing. What does this say?
SP.
No. Read.
1s.
1s. Then they automatically go to the what? 2s. Then they go where? 2p and 3s. And then they go to 3p, 4s. Then they go to what?
3p,
4p, 5s. Then they go to what? 5p, 6s. Depending on how many electrons determines how far you go. Does that make sense?
Yes.
All right. Now, let's regroup a minute. We start at 1s. Everybody agree?
Yes.
Okay, look over. Oh, it's not there. Look at your notes. How many lines do you draw for an S?
1.
Okay. So start over here because your paper is going to look like this on the diagonal. What did I say? Your electron configurations get longer and longer as you go down, yes?
Yes.
Okay. So I'm going to move up and get as far as I go. All right. So I draw one line, take half of your space, draw one line. That is for your s orbital, yes? Your filling sequence is labeling it what? 1s. Does everybody see that?
Yes.
So I'm going to underneath it write 1s. How many electrons do I have to count for in hydrogen?
1.
Okay, so that means I put my one arrow what direction? So there's my one electron. Because I have only one electron in the energy level 1, the S sublevel, I put a superscript telling me how many electrons are there. So my electron configuration is 1s1. What did I just say?
1s1.
Okay? So this is known as my electron configuration, to make sure everybody knows which is what. That's the 1s1. My orbital notation is the line with the arrow. Does everybody understand? Okay. Are you going to draw any lines with arrows on the back page? No. Okay? All right. Now then, I made this statement right here on your notes. Every element's electron configuration ends where it lives, yes?
Yes.
All right. Hydrogen lives at energy level. Let me refresh your memory. These black numbers are all energy levels. What are they?
Energy levels.
First energy level, what block? S. So 1s, what position in S? What does that say? 1s1. Does everybody see that?
Yes.
What's written here?
1s1.
It lives where it ends. Okay. Who's our next element?
Helium. He.
Okay. How many electrons?
2.
2. All right. What is the max number of electrons for this orbital? 2. So, helium lives at 1s what? 1s2. How many arrows do I have to draw?
2.
First one is always what?
Up.
The second one is always?
Down.
Okay. Now, have we counted? Let's double check. We needed 2 electrons. Do we have 2 arrows?
Yes.
Do we have a superscript of 2?
Yes.
2, 2. 1 arrow, 1. 1 on the superscript, 1. Yes? Okay. Now, everybody look at lithium. Okay? What energy level does it live on?
2.
2. What block?
S.
What position in S?
1.
So its electron configuration is going to end at 2s1. Okay? Well, I'm making you understand what this says. Every element's electron configuration ends where it what?
Starts.
Lives. So I know that lithium will end at 2s1. Everybody with me?
Yes.
Because this is giving you an ending point, isn't it? Okay. So I want you to look right here. Every element starts, let me get the right paper. Every single element starts where?
1s.
1s. Now, do you see that the 1s is filled with 2? So this is filled. So I get to take this and copy it for lithium, because the first part of lithium is identical to this. What did I just say? The first part of lithium is identical to this. It takes care of how many electrons? 2. So 1s2, put in my arrows. That's 2. And then where lithium lives is 2s what?
1.
And how many arrows is going in this s orbital?
1.
1. Now let's check. Do we have 3 arrows?
Yes.
Do our superscripts add up to 3?
Yes.
Okay. Now we're adding 1 more electron for 4. Does it make sense that on this one, on, who is it? BE? Does it make sense that 4th arrow is going to occupy right here?
Yes.
Because the S fills up at 2. So I'm copying 1s2. That's the only thing I'm copying, because that S is filled. Now then, beryllium lives at 2s what, kids?
2.
2s2. Everybody see it? Energy level 2. What spot? S2. So it ends at 2s2, and now it has how many arrows in this s?
2.
So do we have 4 arrows? And 2 and 2 make what? Okay. So on my filling sequence, what comes after 2s? Look up at my screen.
2p.
2p. Everybody following me? All right. Go over past BE on the periodic table. Who comes next?
B.
Do you see that B lives at what position? P what? P1. Energy level 2, position P1. That's where its electron configuration is going to end. Everybody with me?
Yes.
All right. Now then, can you see that the 1s2 and the 2s2 are completely filled here?
Yes.
Okay. I am going to carry this with me down to boron. It has 5 electrons. The first 4 is going to look exactly like this. What did I just say?
Raise 4.
So my electron configuration is 1s2, 2s2, and where did I tell you it lived?
1p.
Not 1p,
2p.
2p,
1.
1. Okay? That's its electron configuration. Now I'm going to do the arrows. Copying right up here, 1 up, 1 down. Again, I'm copying right up there, 1 up, 1 down. Okay, now right here is where I have to take you back. How many orbitals do we draw for P?
3.
3. So, 1, 2, 3. You have to show all 3, whether they have electron arrows in them or not. Does everybody understand? If you don't have all 3, it's wrong. Yes?
Yes.
Now, how many arrows am I putting here?
1.
And there it is. Okay? Who's 6? Carbon. It has 6 electrons. So I know it's going to, my S's are going to be just like this. So I'm going to do 1s2, 2s2. Where does carbon live?
2p2.
2p2. Now I want you to get this in your head. It takes how many elements to fill up the P? 1, 2, 3, 4, 5, 6. So we will not fill up the P till we get to neon. Does that make sense?
Yes.
Okay. So we're at 2p2. I must draw 1 up, 1 down. 1 up, 1 down. My 3. And how many up? This is Hund's rule. You cannot put a down arrow next to your up arrow till you fill all 3 up arrows first.
So the next up.
Next one is up. Okay? All right. 7 is who? Nitrogen. 1s2, 2s2. Where does nitrogen live? Hadn't heard it yet.
2p3.
2p3. Okay? 2 for my S. 2 for my S. 3 orbitals. Everybody look at my screen. 1, 2, 3. Whose rule is that? Hans. Okay. All right. Who's 8?
Oxygen.
Where does oxygen live on here? At P what?
4.
P4. Energy level 2, position P4. That's where your electron configuration ends. So I've got 1s2, 2s2, 2p4. And if you're doing this in ink, put the pen down and get a pencil. 2 arrows here, 2 arrows here, 3 orbitals drawn. Okay, 1 up, 2 up, 3 up, and the 4th one comes back and starts the first what? Down. Okay? Everybody good so far? So we're adding 1 more electron. So add 1 more to this. Where does fluorine live?
2p5.
Exactly. See all the patterns emerging? Okay, so this is fluorine. 1s2, 2s2, 2p5. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do we have 9 arrows? Do we have 9 arrows showing? Well, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes? Now add your subscripts. 2 and 2 is 4, and 5 make what? 9. Do you remember your arrows and your superscripts have to total to what? The number of electrons, yes?
Yes.
Okay. So who is element 10? Okay. How many electrons are we counting? 10. Where does neon live?
2p6.
2p6. So 1s2, 2s2, 2p6. Do you see that we stayed on the p's for boron, carbon, nitrogen, oxygen, fluorine, and neon? Does everybody see that? Guess what is full now when we finish neon? The p. 1 up, 1 down. 1 up, 1 down. 3 orbitals for the p. 1 up, 2 up, 3 up, 4 down, 5 down, 6 down. Okay. S is filled, S is filled, P is filled. Why am I going to circle this? Because every element from this point on will have exactly all of this plus an increasing amount. Does everybody understand? This is good for 10 electrons. So element number 11 is sodium. What energy level does it live in? The 3. What block? S. What position? 1. Let's look at this and see if we're holding true. 1s, 2s, 2p, and it tells us that we go to 3s. Okay. So this is sodium. I got 1s2. I'm literally copying what's in front of me. 2s2, 2p6, and we said sodium lives at 3s1. There's its electron configuration. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Add up your superscripts, add up your arrows. Do they all total 11? Everybody hanging in? Ask me questions. Anything you do not understand. Who's number 12? Where does magnesium live? Uh-huh. So that extra electron will take up the second position in the 3s, won't it? 1s2. Whoa, that's not an S. 2s2, 2p6, 3s2. Do you remember do you see that I will never ever double up on my P's without putting all 3 up arrows first? I'll train you that way so you don't screw up on the test. If you get in the habit of going down, up when they're filled, you'll screw up and do down, up on the test. Does everybody understand?
Yes, ma'am.
And I'll catch you. Okay, can you see that everything else here is what? Is every S and P filled? That means every element from this point on will have all of this plus more. Yes?
Yes.
Okay. So my next one, go across to aluminum, which lives in what block? So it lives at 3p1, doesn't it? Everybody see that? So I'm going to copy all of this. 1s2, 2s2, 2p6, 3s2, 3p1. Everybody agree? Okay. Put in your orbitals and arrows. 1 for S's, 3 for P's. Everybody stop and take a look at my screen. 1 for all the S's. How many for all the P's? 3. Do you ever get to drop anything? No. This one is filled. This one is filled. This one is filled. This one is full. And this one only has how many?
Wait, why? Oh, it's back on.
Everybody still with me? All right. So, how many elements are we going to go through before we get to argon? 1, 2, 3, 4, 5. Argon makes how many? 6. So, you'll be at 3p1 here. 3p what here? So, does it make sense? You can just sit here and write it. 3p what here? 3p what? 3p what? And 3p 6. All right. So we got Al, Psi, phosphorus, sulfur, and chlorine. Psi. Okay. Phosphorus, sulfur, chlorine, and argon, right?
Yes.
All right. So I can sit here and do what? Does everybody see how it becomes very repetitive?
Yes.
All right. After you finish argon at 3p6, you go over to 19. That starts 4s1. Does everybody see that?
Yes.
Follow the filling sequence. Do not deviate.
We got 4s1, 4s2, and then
Look at it. 3D. See it? Okay?
it'll take a little bit, but